Imagine this. You're in a data science interview and the interviewer says, your model flags a transaction as fraudulent, but it's actually legitimate. Or it misses a real fraud completely. Which is worse, and how do you balance them? That's your cue to talk about type 1 and type 2 errors, two sides of the same statistical coin. Let's make it simple. A type 1 error is a false positive. It's when you think you found something, but you didn't. Like a fire alarm going off when there's no fire. In statistics, it means you rejected something that was actually true. A type 2 error is a false negative. It's when you miss something that's really there. Like not hearing the alarm when there is a fire. Statistically, it means you failed to reject something that was false. You can think of it like this. Type 1 is crying wolf. Type 2 is missing the wolf entirely. Now look at the examples on the slide. Declaring a drug effective when it's not? That's a type 1 error. Missing a drug that actually works? That's a type 2 error. Both are costly, but in different ways. And understanding when each one matters is what separates good data scientists from great ones. Now let's talk about how this actually plays out in the real world. Because interviewers love to see if you can connect statistics to impact. Different situations demand different balances. In medical testing, missing a disease, a type 2 error, can be catastrophic. So doctors prefer to tolerate more false alarms if it means catching every real case. In other words, it's okay to scare a few healthy people if it saves lives. But in fraud detection or spam filtering, the priorities flip. Too many false positives, flagging real transactions or emails as fraud, can frustrate users and damage trust. So in those cases, you tune your model to reduce type 1 errors, even if it means missing a few actual frauds. Here's how you could answer this in an interview. A type 1 error is a false positive, rejecting something true. A type 2 error is a false negative, missing something that's real. In my spam detection project, I adjusted thresholds to minimize type 1 errors, because it was more important to avoid marking legitimate emails as spam, even if it meant missing a few actual spams. That's the kind of answer that shows real judgment. You understand not just the statistics, but how to apply them intelligently in context.